Percentage purity and percentage yield. Percentage purity and percentage yield are what we're going to be looking at today. So I'll start with purity. This is the ratio of the pure substance to the impure substance expressed as a percentage. This means the amount of pure substance compared to the total mass of the substance the pure substance came from. If the masses are equal, then the purity will be 100%. It means whatever reactant you had was actually pure. So these percentage purity calculations are there to just check if your reactant is pure or not. Many substances are usually impure, hence have to be purified before use. The formula is there. Percentage purity is equals to mass of pure reactant over mass of impure reactant times 100%. We have ended here with percentage purity. I skipped to percentage yield. This is the ratio of the actual yield to the theoretical expressed as a percentage. The ratio of the actual yield and the theoretical expressed as a percentage. Yield, of course, is produce or harvest. A yield is a product, a produce, or a harvest. Actual yield is achieved through physical experiments and is never 100% because of side reactions and fluctuations in optimum conditions, which may result in some reactants not to react. So in reality, chemical reactions never really give you 100% of what you'd calculate for in theory. So to compare what you have gotten in reality and what you would have gotten in theory if things were perfect or ideal under ideal conditions and ideal conditions, we express that as a percentage yield. Percentage yield, the formula is there. Mass of product obtained over mass of product expected times 100. Thus, mass of actual yield over mass of theoretical yield times 100. The other way of writing it would be like this. Percentage yield is equals to actual yield, of course, over theoretical yield times 100. 3 questions. My first question is there. What mass of potassium carbonate is produced when 1.5 grams of potassium dioxide is reacted with an excess of carbon dioxide according to the reaction? If the reaction is or has a 76% yield. You're given the balanced or a balanced chemical equation here. Your chemical equation always has to be balanced because it will give you what we call fixed mole ratios that you use as you relate in your calculations. Our formula is here. Percentage yield is equals to actual over theoretical times 100. Our percentage yield in the question is 76, and our theoretical yield is 1.458 grams. How did I find this 1.458? We pause here, we get to how I found this. In theory, 4 moles of potassium dioxide react with carbon dioxide, which is in excess, to give us 2 moles of potassium carbonate. So in this equation, by mass, check out my video on how to read a chemical equation or the chemical equation. So by mass, 284 grams of potassium dioxide will react to give us 276 grams of potassium carbonate. Therefore, if this gives us this, then 1.5 should be able to give us x. So x is equals to, I make x my subject here, then I show in full how my calculation is actually or has proceeded. So 1.5 grams times 2 moles times 138 grams. These 2 moles is this same 2 moles here. So this is the molar mass of potassium carbonate multiplied by 2 moles, then multiplied by this. So this 1.5 times this, I obtained this by finding 138 and then times 2. So this is how it's supposed to be expressed in full, divided by 4 moles times 71. 71 is the molar mass of potassium dioxide, potassium dioxide, but since it was 4 moles, so 4 moles or 4 times the molar mass, giving me 284. So this is how the whole expression is here. I summarize it, but this is what I did for me to find this and this. So finally, my theoretical mass or my x would be this. So if 1.5 grams were to react with excess carbon dioxide, this is the mass of potassium carbonate that would be there in theory under ideal conditions, under perfect conditions. So this is my T, theoretical mass. So I divide by 100 on both sides because I have to get rid of this 100 on this other side because I've already been given the percentage. percent. Cent means 100, so per 100, so over 100. This divided by 100 gives me this. This 100 cancels with that 100, then I have this. So my actual yield finally gives me 1.1 grams. If the yield is 76, then my actual yield, if the percentage yield is 76, then my actual yield would be 1.1 grams when this much reacts with excess carbon dioxide. Second question, if 100 grams of iron oxide produce 12.9 grams of pure iron according to the reaction, what is the percentage purity of the iron oxide used? This one is about percentage purity, and the formula is as shown there. Percentage purity is equals to pure reactant over impure reactant times 100. So percentage purity is going to be equal to 16.5, okay, 16.59 grams divided by 100 grams times 100. My pure, here the main issue here is us finding the pure, the mass of the pure reactant, because the impure is given. So our initial reactant here, the 100 grams, is taken to be impure because we're not yet sure if we can get 12.9 grams of iron from this much iron oxide, iron 2 oxide. So what do? We simply calculate using our balanced equation. We work backwards to find the amount of reactant which would give us the 12.9 grams. Therefore, the amount of iron oxide that would give us the 12.9 grams under ideal conditions. So from my balanced equation, 2 moles of iron 2 oxide reacted with this species here to give me 2 moles of iron. So 2 moles times the mass of iron oxide gives me 2 moles times 56 grams or the mass of iron. Therefore X should give me 12.9. Therefore this 12.9 grams of iron should come from this much X, and this is our pure substance. So when I rearrange this, it gives me this. X is going to be equal to 12.9 times 2 moles times 72 over 2 moles times 56, giving me 16.59 grams. This is the mass of iron 2 oxide that would give us 12 grams of iron. So already I can tell to say this substance it's either it didn't react to the completion or it was impure. Those are the two assumptions I would make, but I will take the path of the impurity. So it means if this much is the mass of iron 2 oxide that would give me 12, then it means this is already below 100%. So I plug in my pure mass of reactant over the impure or the initial mass of the reactant times 100, then I get my 16%. That is the percentage purity of our 100 grams of iron oxide, the percentage purity of our 100 grams iron oxide. So meaning in this 100 grams of iron 2 oxide, there was only 16.5 grams of 0.59 grams of pure iron 2 oxide, and that is the reason why we got 12.9 grams of iron. If it was more than this, under ideal conditions, it will actually be more than 12 because because it would be more. So my last question, when 15 grams of methane is reacted with an excess of chlorine according to the reaction, a total of 29.7 grams of chloromethane is formed. What is the percentage yield of this reaction? So this one goes back to percentage yield, where you have percentage yield is equals to actual over theoretical. Then as usual, I have to find my theoretical mass of yield. So I go to my balanced equation, which would give me my fixed ratios. 1 mole reacts with 1 mole to give me 1 mole and 1 mole of HCl. So my concerned species are methane and chloromethane. So 16 grams of methane, the mass of this, there's no coefficient here, so I'll not multiply this with any coefficient here because it's 1 mole. So 1 mole times 16 is 16. Gives me 50.5. The molar mass of this is also 1 mole, so 1 mole times 50.5 will still give me 50.5. Therefore 15 grams would give me this. So I rearrange this by cross multiplying to give me 15 times 50.5 divided by 16 to get my theoretical mass. So in theory, 15 grams of methane would react with excess chlorine to give me this much grams of chloromethane. okay, but in the actual experiment we found that it was, or according to this question, it was found that it gave 29.7 in the actual experiment. So actual over theoretical. My actual is this, then my theoretical from my calculations should be this, and then when I do my calculations here, it gives me 62.7%. that would be my percentage yield, 62.7%. okay, so basically that's all I had for you in this video. Remember to like it, share, and leave your comments, and hopefully it helped you in one or another. Bye bye for now.